Okay? Okay, so there is something else. Okay, if we have a wire like that, okay, or let's say if we have a rod like this. So this is actually a metallic or conducting rod or a wire, and then we place this one in a magnetic field like this. Okay. Now we don't have any current here. What we have a velocity. So this rod or this wire is moving with a speed v. In this case, when this one starts to move, we know this is a conductive. Is it conductive? So it's full with charges. So let's say that this has a positive, and negative also at the same time, because this is actually just a normal rod, okay? And it's actually balanced, everything is nice there, but it's a conductive one. So if we just give an external voltage, the electrons will move, okay? But we know, don't forget this, that the current or I is a motion of what? Yes, motion of positive charges with respect to negative ones. Okay. So when we say I, so that means positive charges are moving. Okay? Don't forget this. This is actually, we explained too much before. Okay, so now let's consider now again this scale, which is the right hand rule. So this is going up like that. Okay, magnetic field is going inside. So now the palm, okay, is just pointing, the force now pointing this direction. So this magnetic force, which is applied on the rod here, they start to push these positive charges to move to the left here. Okay, so they start to move like that in this case. Okay, so this is we call it induced EMF. Induced EMF, electromagnetic force. Oh, sometimes they call it just E, okay, which is the induced EMF here. So if they are moving from here to here, that means here it has a high potential, and here we have low potential. Okay? So that means here it has high voltage, high potential and high voltage, and here low potential, low voltage. Okay? So now we have a current direction to that side. This current also we call it induced current. Okay, so it's also induced current. Okay, so let's do the same example now, but we change the direction of the current. So let's see the current like that. Sorry, the direction of the magnetic field. Okay, so this is the new direction of the magnetic field. And we know this is just, this is just the front of the arrow here. So the magnetic field is coming away, out. So this is the B. Here also it was B here. So this P now tells us that all the lines are coming from the board to us, like that, outward from the whiteboard. And then we have this rod placed here. Okay. This rod, this wire, whatever. Okay. So without moving the rod, so there is no effect. There is nothing will happen here without moving the rod. If we just move the rod down here with a speed v. So in this case, let's now apply G right hand rule. So all your four fingers will be out because the magnetic field is out, and the direction now is, or the V is going down. So again, the force will be to that direction because the force will be perpendicular to the palm of the hand, like that. Okay. So here we have these positive charges will move to this direction. So we have the current is in that direction. Okay. So let's make it larger like that, or maybe bring another color. Yeah, here the green one. So this is the current will be in that direction. Okay. Okay. But let's now make this one, little bit complicated. Not complicated, just we add something to this now. What is that? So now we have the current. Let's do this. Okay. So now we have the current is moving to that side. Over this, same thing. Okay. So if the current is moving to the top like that, this current carrying wire will produce a magnetic field here. Okay. So this is going up, so we have magnetic field is going inside in this area, whole area, as you can see. And on the left part here it will be coming out, as you know from before. Okay. Now these are induced actually magnetic field by this current. Okay. So they are coming from this current. So this current initiate or starting this magnetic field. Without this wire carrying the current, there is no magnetic field in these areas, both these two areas. Okay. So first of all, the current here, or the wire carrying current, produce the magnetic field. Secondly, somebody come across and then he placed this rod here again. Okay? And this rod actually is moving with a velocity to the top, for instance. Okay? So now we know that there is a magnetic field and there is a rod moving to up with a velocity v, and then we can find the induced epsilon here. Yeah, it's easy for us because, as we said, up inside, so it will be like that. So the current will be here, moving that side. But even though the current will not continuously moving, okay, just for a small short of time, because this will be an open circuit. It's not that closed circuit, so we need to close this wire or connect it to a circuit so then this can flow and continue flowing in that circuit. But what I'm trying to say here, that this magnetic field is actually produced with another wire. Okay, so we have wire that produce magnetic field, and then we have here a rod that can also be affected with this magnetic field here. Okay, hopefully this can help you